and welcome back to my channel. Today I'm going to be giving you a crash course on derivative rules. There are a lot, so bear with me. So there are three ways that denote telling you to find a derivative. So those are, if we say we have a function f of x, you say dy dx of our function f of x. And then that is equal to f prime of x. So this literally means taking the derivative of y with respect to x. You may also see it written this way without the y, so d dx is equal to f prime of x. It's the same thing. You might also see, less commonly, but also a possibility, you might see just f of x and then an apostrophe, a little prime symbol to signify. Today we're going to be using this notation. All right, let's go ahead and get into the derivative rules. So these are pretty fun. They help us find the derivative without having to use the definition. And they are a lot easier and quicker than using the definition. So first off, let's start off with a constant rule. That is, if we take the derivative of some constant c, it's equal to 0. So for example, if our f of x is equal to 4, our f prime of x is equal to 0. Our next rule is the constant multiple. So that means if we have dy dx of some constant c times a function f of x, it is equal to c times f prime of x. So an example of that would be if f of x is equal to 4x, then f prime of x is equal to 4 times dy dx of x, which we'll get into this later, which is just 4. All right, next up is the power rule. This one you will probably be using the most. That says that if we take the derivative of some value of x to the n power, it is equal to n times x to the n minus 1 power. So I know that kind of looks like a lot, but bear with me, it's actually quite simple. So if we take a function, f of x is equal to x to the third, our n here is equal to 3. So we're going to pull the n out and we're going to put a 2 up top. So our f prime of x is then 3x squared. So if you see here for this, we have 4 times, it's going to be 1 times x to the 0, which is 1 times 1, which is equal to 4. Next up, we have the product rule. So we take dy dx of two functions, f of x times g of x, will be equal to, bear with me here. You may see this 2 different ways, but it will be the same nonetheless. F prime of x times g of x plus f of x g prime of x. Or the way that I learned it was this handy little saying that was first d last. So f of x times the derivative of the last one, wait a second, plus last, d first. And then these are the same equation, just switched around a little bit, but they're the same thing because it's addition. So let's say we are given the function 2x squared times 3x. So we could just expand these out and apply the power rule, but let's use the product rule right now and say that f of x is 2x and g of x is 3x. So then f prime of x becomes first d last. So it's going to be 2x squared times the derivative of 3x. Using the power rule, this is just 3 plus last, which is 3x, d first, which would be, using the power rule, this will be 2 times 2, 4x to the 1, 4x, and then we can just expand this all out, which is equal to 18x squared. And then if we really wanted to use the power rule, we could expand this out and we would get 6x cubed, in which then we would find that f prime of x is 3 times 6 times x to the 3 minus 1 power, which is 2. And that is the same answer. Next up we have the quotient rule, which is, I have to say, the most annoying one to use. It says that we take the derivative of some function f of x divided by another function g of x is equal to, here I have another handy dandy little saying to remember it, low d high minus high d low all over low low, gx squared. So this is gx times f prime of x minus f of x g prime of x divided by g of x squared. Say we are given the equation f of x is equal to x to the fourth divided by 3x. Like before, we could just simplify this out and use the power rule, but right now we are using the quotient rule, so that's what we're going to use. So that means that f prime of x is equal to low d high, which is using power rule, 4 times x to the 4 minus 1, which is 3. So low d high minus high d low, which is just 3, and then divided by low low, which is 3x squared. And then we can expand and simplify to get 12x to the fourth minus 3x to the fourth divided by 9x, which is 9x to the fourth divided by 9x squared. And then we are left with x squared. So if we see here, we can, if we simplify this, we get 1/3 x to the third. And then when we apply the power rule, prime of x is then 3 over 3x squared, which is equal to x squared. We have the same answer both ways. Next up, we have the chain rule, which means that if we take the derivative of f of g of x, we get f prime g of x times g prime of x. So you take the derivative of the outside times the derivative of the inside. So say we are given the function f of x is equal to 3x squared plus 2 quantity squared. The way to do this is we want to find the derivative. So we're going to take the derivative of the outside and treat the inside like x. We leave the inside the same. So we have a 2 out there. So we take the 2 down front using the power rule. The inside stays the same. And then we subtract 1 to get 1. And then we multiply by the derivative of the inside. So using the power rule here, we are going to get 6x plus 0. So I'm going to leave that like that. And then this is pretty much the example, but we can simplify it a little bit more to get 36x cubed plus 24x. That's our solution. So finally, we're going to be talking about the derivatives for natural log of x and e to the x. So these functions are different from the other functions we just looked at. So if we want to find the derivative of natural log of some f of x, some function inside, it's equal to f prime of x over f of x. So if we wanted to find the derivative of natural log of 2x squared, we would get the derivative of the inside is 4x divided by 2x squared. And then we can simplify this and say that this is then equal to 2 over x, and that is our solution. So the other unique function that we will be looking at is taking the derivative dy dx of e to some function f of x. This is equal to f prime of x times e to the f of x. This is a really fun equation because if we wanted to take the derivative of e to the x, it's equal to e to the x. Let's do a more detailed example. So if we wanted to take the derivative of e to the 2x squared, this would be the derivative of the exponent, so that is 4x times e to the 2x squared. That's the solution. Thank you so much for watching. This has actually been part of my final project for my maths degree. If you have any questions, I'd be more than happy to answer them in the comments below. Once again, thank you so much for watching and have a great day.